Welcome to the final video in our series on building an end-to-end ML pipeline. I'm James Coffey, and today we'll go into our Directed Acyclic Graph, or DAG, that we ran in our pipeline. Here you'll see the whole process we built come together. I'll walk you through the code and explain the helper functions that make our DAG operate. This will give you a comprehensive understanding of how each piece of our pipeline fits into the overall workflow. Our DAG is written in Apache Airflow's classic syntax. It's robust and has been the standard for many workflows. However, there's always room for improvement. While this DAG could be streamlined if written in Airflow's Taskflow API, which offers a more modern approach with less boilerplate code, today we're sticking with the classic to keep things straightforward. I won't cover the Taskflow API in detail in this video, but I've included a link in the video description for those who are interested in exploring this newer method. Let's go through the DAG and see how each task is defined and how they interact with each other. Let's go step by step through our Airflow DAG. First, we're going to import some custom modules. Here, we're importing the configuration file that we set earlier. Next, we import our helper functions to make our DAG look cleaner. Then we import some operators. Some are specific to Amazon AWS. Afterwards, we use our configuration.py file to set some configuration variables for our DAG. Then, we define our DAG. The DAG ID is a unique identifier for the DAG. Here, it's SageMaker ML pipeline. Our schedule interval is none. It must be triggered manually as a result. Our start date determines when this DAG is considered valid. Here, it's valid from January 1st, 2021. For our tag, this DAG is tagged with MLOps, indicating its purpose. Catch-up is set to false to prevent Airflow from backfilling past runs. Now let's go through the tasks defined in our DAG. First, we're going to list the S3 files. S3 list operator lists files in the dataset bucket with a prefix of raw and pushes the results to XCOM. From our helper functions, pass2string constructs a comma-separated string of S3 paths for files ending with CSV. The next step creates an EMR application. EMR serverless create application operator creates an EMR serverless application for Spark jobs, outputting an application ID. EMR serverless start job operator runs a Spark job to pre-process data using application ID, the EMR role ARN, and these configurations. The job runs a script located in the Airflow bucket. Here it's called preprocess.py. Now we don't want to keep our EMR serverless cluster up and running. Therefore, in the next step, we delete our application. Here, the EMR serverless delete application operator deletes the EMR application after the job completes. Next, we prepare configurations that we need for training and hyperparameter tuning. This Python operator runs prepare configs to set up configurations needed for the SageMaker job, passing the dataset bucket and the SageMaker role ARN. Next, SageMaker tuning operator launches a SageMaker hyperparameter tuning job, using the configurations from prepare configs task and waits for completion. Next, a Python task is used to adjust configurations based on the results for model tuning. This function addresses an issue where a new S3 submission directory is created for each chunk of data during the model training process. This leads to a mismatch in the expected S3 path in subsequent SageMaker operations. This function ensures that correct S3 paths are used. Next, after training our model, we perform a batch transform on our data. This batch transform task performs predictions on a batch of data using the trained model. It's configured to wait until the transform job is complete. Afterward, we evaluate our model with the evaluate model task. From our helper functions, evaluate model evaluates the machine learning model by comparing predictions to ground truth values. It computes the average precision score of the predictions and compares these scores against a benchmark value stored in a text file within the same S3 bucket. Next, we call a helper function. This function, called deCideNextTask, determines the next task in the workflow based on the result of a model evaluation. Depending on the evaluation result, this function will return the name of the next task to execute, deploying a SageMaker endpoint if the evaluation was successful, or sending a failure notification otherwise. Since our evaluation was higher than the benchmark, we'll deploy our endpoint. In this task, we deploy a SageMaker endpoint using SageMaker endpoint operator. After our endpoint is deployed, we use a dummy operator to declare that our pipeline is complete. Now, with our DAG and our tasks defined, we set our task dependencies. The DAG's tasks are connected in a way that reflects the dependencies of a typical ML workflow. We start with data listing, and we move through preprocessing, tuning, and end with deployment. The tasks are connected with a double greater than operator. This sets the order of execution in Airflow. That's it. Thank you for sticking around and watching till the end of this end-to-end pipeline series. We've covered a lot, from setting up our AWS environment to running complex machine learning workflows using Apache Airflow. Check back for more videos and series in the future. We'll continue exploring more advanced topics and new technologies in the machine learning and data science space. Your engagement and feedback have been invaluable throughout this series. If you have any questions or need any further clarification on things that we've covered, please leave a comment below. Make sure to hit like, subscribe, and that notification bell for updates on new content. Thank you for watching, and I hope to see you in future videos.